Okay, so hello everyone. So in this video, what I want to do is I want to go over the product rule for derivatives. Now, I'm trying to see exactly what I can, because honestly, if you're very new to this, I want to explain it in the way that it is as clear as I can make it. Because honestly, yeah, I mean, the first thing that I really want to go over before anything, before I even go over the what is it called? Before I go over the product rule, is so basically the first thing that I want to go over is trig derivatives. Now, there is I'm going to do this in kind of a different way, okay? I'm just going to do derivatives. So I'm going to say that the derivative of sine, like I said in the last video, the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x, okay? Now, so those are the two derivatives that we want to just focus on for right now. And I don't want to do like derivative of tan or derivative, because those require you to, like, for me to actually do that, I have to do quotient rule, and I don't want to do that in this video just yet. So we're just gonna go ahead and do product rule for derivatives, but we're gonna do it in the way that that basically makes, not that it makes sense, but we're gonna do it in the way that I'm not, introducing new terms. Okay. Now there is one derivative I forgot to mention in the last video. That's d dx of ln of x is 1 over x. That's one thing I forgot to mention. This is the natural log derivative, okay? And also d dx of log base b of u, or really it would be d dx really, but yeah, log base b of u. And I'm gonna actually do ln of u because it'd be 1 over x times du. And then log base b of u, that would be, oh my, I forgot the derivative for this one. I didn't, when I was in Cal 1, we never did these, but we did do them in Cal 2. It would be, it's not 2 to the x ln of u. It's something else. It's oh my gosh. I'm just gonna look it up. I'm gonna look it up because I don't remember the derivative for that one. That one's a little more complicated. Give me 1 second, guys. Okay, so this one is gonna be, so the derivative of this is just gonna be u prime over u ln of a. Or ln of b, excuse me. And I'll go more over that once we get into log derivatives. But yeah, that's the rule. It just means that you're going to take the derivative of the inside and then divide it by whatever's inside the log, and then take the natural log of whatever base the original logarithm has. That sounds really confusing, but basically if I have, for example, log base 6 of 5x, the derivative would be 5x prime over 5x ln of 6, natural log of 6, and then that would be 5 over 5x ln of 6, and then that would be, it would be 1 over x ln of 6 in reality. That's how you would do it. I mean, the book doesn't go over that until like later on, but I'm going over it now because since we're doing derivatives. So I'm gonna go ahead and do product rule. Oh, and also the derivative of e to the x is just gonna be e to the x. That's another one that I forgot to go over. I'm trying to think of what other ones I didn't go over yet. I think that's it. I think those are most of the derivatives that we will encounter in Cal 1. There are more, like there's sine inverse, but I'm going to do that in another video. But for this specific video, I'm just going to focus on product rule. So anyways, let's begin. I'm just going to do some very simple ones. So we have, for example, find the derivative. So f of x equals x squared sine of x. Okay, so we want to find the derivative, okay? What you're going to do, and remember, the derivative of sine of x is cosine of x. So you can pause this video and try to see for yourself how to do this one. I'll give you a hint. It's f prime g plus g prime f, okay? Where this is f, this part is f, and this part is g. So this one, hold on. This part is g. Okay. So you can pause the video and you can see if you can do it yourself. Okay, so the way that we do this one, you're going to want to find f prime first. So always, the first thing you're always going to do, you're going to say what f equals. So you're going to say f equals x squared. And then you're going to say, oh, and this is, by the way, this is, the product rule says this, d dx of f times g, or fg, equals f prime g plus g prime f. Okay, now I'm going to go ahead and try to like color code f prime and etc. So we have f equals x squared. That's the first part, the first function that we start with. G is sine of x. Okay. So so really we have so let's see, hold on. This is G, and then f prime is gonna be, I'm gonna do this in a very creative way, because I want to start to, because once we get into implicit differentiation, you'll understand why I put dx, if that makes sense. So this one is going to be, so f prime is going to be 2x, and then it's going to be dx over dx, okay? And this is not how you would do it in integration, though. Integration, once you get later on to integration, like, you're just going to put it like this, okay? And then g prime is going to be cosine of x, okay? Now, because it is with respect to x, we're going to go ahead and just take the dx off, because we're taking the derivative with respect to x. This is not the same as taking integral. It looks very similar, but it's not. They do go hand in hand, but integral is calculus too, so please don't get confused. So f prime is this one, and then g prime, I'm going to put it like this. So now our function is going to be f prime of x equals f prime g plus g prime f. So then we have, so basically it goes like this. It goes like this. So we have f prime, this is f prime here, and then we have g, which is like over here, okay? And then we have g prime, which is over here. And then we have f, which is like right here. Oh wait, f is orange, my bad. Right here. So you're just going to go ahead and plug it in. So you're going to have, this is equal to 2x times sine of x plus cosine of x, put it in parentheses, times x squared. Now, be careful. That doesn't mean that it's going to be cosine, because there's a difference. Cosine of x times x squared does not equal to cosine of x times x squared. Okay? That's we should already know that by now. So really, you're going to say this. The way that you would write it is like this. You're going to say 2x sine of x plus x squared cosine of x. Okay? And that is your derivative. Now, I'm trying to think of other ones. So, let's try to do one that goes like this. So let's say ln of x cosine of x. Ln of x, like literally ln of x, the natural log of x, all of that, times the cosine of x. Let's do, this is f of x, okay? How are we going to do this? So basically, remember I said d dx of ln of x, and I think I set it up here. Yes, I did. So basically, d dx of ln of x is just 1 over x. We should like literally memorize that. The derivative of natural log is 1 over x. And the derivative of cosine of x is going to equal negative sine of x. Okay? I highly recommend that you guys memorize derivatives, because I mean, depending on what school you're in, and depending on whether or not your professor lets you use your derivative tables or your derivative formulas for exams, if they don't let you use it, I really recommend that you memorize it, or you practice it over and over until you know your derivatives, because that's literally what I had to do when I was in Cal 1. and it's hard. It takes time. Like, honestly, when I was in Cal 1, I was not really good at derivatives. Until then, I went on to Cal 2, and then I understood derivatives better. But I had to, like, literally practice derivatives over the summer before I took Cal 2, so that I could understand that in order to then understand integration. But anyways, I'll just say that by the end of my Cal 1 semester, I understood derivatives completely by then, but it was hard throughout the year. So yes, it takes time. So ln of x is f, and then cosine of x is g, so that means that we have f equals ln of x, g equals cosine of x, f prime equals 1 over x, and then g prime is going to be negative sine of x. Okay, so let's apply the rule. We have f prime g plus g prime f. And this is a shortcut, by the way. Like, you don't have to remember this stuff. F prime of x times g of x plus g prime of x times, because that's really long. My professor taught us this way. F prime g plus g prime f. Literally. That's the shortcut way of doing it. Anyways, so we have, so f prime is 1 over x, we have 1 over x times g, so that's going to be cosine of x, plus g prime, that's negative sine of x, times f, which is ln of x. So what is this going to be? This is going to be, so f prime x is going to be equal to cosine of x, so we have f prime of x, f prime of x equals cosine of x over x minus sine of x ln of x. Okay. Note that sine of x and ln of x are two different functions. So if it helps, put it in parentheses, put both of them in parentheses. Or you can also do it like this. So you can say cosine of x over x minus sine of x times ln of x, like this. Both of these ways work. Okay. Now, I'm trying to think of another one for product rule, because I'm not 100% sure. I mean, I have my book here, but it only goes up to an extent, and like, trust me, I'll have a lot more examples once we get to quotient rule. Give me 1 second, guys. Hold on. Okay, so let's pretend we have this one. Now I know what you're thinking. How are we going to take the derivative of this? Because we have a sine cubed x. Okay. There's a way to do this. You can do the following. Okay, so watch carefully. F of x equals cosine of x, and we're going to do the following. Times sine of x times sine of x times sine of x. Okay? So we're going to first do, let's first do this part. Okay, let's take the derivative. Okay. So let's pretend that this entire part is f, and let's pretend that this entire part is g. Let's do, so f equals sine of x cosine of x. Okay. Now, f prime is going to be the derivative of sine of x, so it's going to be, we have, let's pretend this is u and this is v. U prime is cosine of x. So basically, u equals sine of x, du dx, the derivative of u with respect to x, excuse me, is equal to cosine of x. And then we have v is equal to cosine of x, and the derivative of v with respect to x is equal to negative sine of x, okay? So we have f prime equals u prime v plus v prime u, okay? I'm putting them in parentheses so that way we don't get confused. Okay. So f prime is going to be, so in reality it would be like this, du dx times v plus dv dx times u. This is how I remembered it. I know they usually do it like, they would say, oh, it's, so basically the derivative of fg is equal to f prime g plus fg prime. And that's confusing to me. If that works for you, that's great. But I always like to do it as d dx of f times g is equal to f prime g plus g prime f. That's just better for me. That was easier for me to memorize than this. So that's why I do it that way. If that's easier for you, or doesn't, not this way, but the f prime g plus g prime f way. That's how I do it. If f prime g plus g prime f sounds easier to you, then by all means go ahead. Also for this, f prime g plus fg prime. The only reason why I find this very confusing is because, like, I would always think that fg prime is like literally this. So that's kind of why I don't like it. That's why it's easier to just say g prime f. But whatever sounds easiest to you is, you know, you can use however, you can think about it however you think is best. But yeah. So f prime is going to be, so we have, so u prime, so du dx is cosine of x, right? And then we have times v, so we have times v cosine of x, and then plus, and then we have v prime, so u prime v plus v prime is dv dx, really. So let me try to color code this really quick, guys. Just give me 1 second. If you're confused about this, about these notations, I mean, in reality, like, okay, so, okay, I'm just gonna put this as, so, okay, let me let me fix this. Okay, so I'm just going to say that this is u prime, and then v prime is this one, okay? I mean, when you get to integration, you're not going to say dv dx and du dx because integration is just different. So I'm guessing, I guess from now on, we're just going to refer to so we're just going to say that, we're just going to say u prime, and then u prime is equal to cosine of x, and then v prime is equal to negative sine of x, because I really don't want to confuse anybody here. The thing is that once we get to integration, the way that we do this is going to be a little bit different, okay? But we're not there yet. So this is going to be, so in reality, this is going to be, it's like I said, this is going to be u prime, u prime v plus v prime u, okay? We know what u prime is. U prime is cosine of x, and then times v, which is cosine of x, and then plus, and then v prime is negative sine of x, so we have negative sine of x, and then times u, which is sine of x. It would be like that. And so then we have f prime equals cosine squared x minus sine squared x. Oh, but look at that. You see? What is this? What does this remind us of? It is the double angle identity. Remember how I said cosine of 2x equals cosine squared x minus sine squared x. So this, in reality, the derivative of sine of x cosine of x is cosine of 2x. If I'm taking forever, guys, I'm sorry. I'm trying my best to explain everything, okay? If you're looking for more of a faster, I mean, you can, of course, you can just go move on in the video, but yeah, I go very slowly because I really want to make sure we understand this. Okay, so that's the derivative of sine x cosine x. That's f prime, okay? This, so basically f prime here, for this part here, we know that f is cosine x sine x. Now we know that f prime is going to be what we just said, cosine of 2x. And then we know that g equals, so we know that g is equal to sine x times sine x, right? And we want to know what is the derivative of g. Now g equals sine x times sine x. So we're going to say g prime equals, it's going to equal, so it's going to be the derivative of the first, so it's going to be cosine x, because this is f, right? So f prime is cosine x. Actually, you know what? Let me put a. Let me put this as a. A equals sine x, and b equals sine x, because I really don't want to confuse anybody here. So that means we're going to have a prime b plus b prime a. So we're going to do cosine x a prime times sine x plus b prime, so it's going to be cosine x times a sine x. And this means that g prime is going to be 2 sine x cosine x. And look at that. What does that remind us of? That reminds us of the double angle identity for sine. Remember? Because sine of 2x is equal to 2 sine x cosine x. So this means that g prime is really just sine of 2x, okay? So we know that g prime is sine of 2x. Now let's put this all together. Let's put this all together. F prime of x, so we know that f of x equals cosine of x times sine of x. So I'm going to say it like this, cosine of x times sine cubed of x, and we have f of x equals cosine of x times sine of x times sine of x times sine of x. And we know that f prime of x is going to be the following. Hold on. Okay. It's going to be the following. And let's actually color code these. So I'm going to just do this. This color. Give me 1 second, guys. I'm going to color code these. Okay, so like this, basically, this is what I'm trying to say. Okay. I'm doing it as f prime g plus g prime f. So I'm going to say cosine of x times sine of x is f times, and that's actually the well, no, that's actually the function, right? I'm going to say f prime, so like I said up here, f prime is cosine of 2x, okay? F prime, so we're going to say f prime of x equals cosine of 2x, that is the f prime, this part, and then times sine x, or rather sine squared x, really, and then that is this part here. This is g. So this part is f prime, this part is g, and then plus, and then we have g prime, which we said up here was what? Sine of 2x. So we have sine of 2x times whatever f was, which was cosine of x sine of x. Okay. Now, this is g prime, this is f. And let me color code that really quick. G prime, and then f was this part here. So now we have f prime of x equals cosine of 2x sine squared of x plus sine of 2x times the sine x cosine x. Now there's a few ways that you can write this. You can write it this way, or you can say the following. F prime of x equals cosine, so let me see, hold on. sine squared x times a cosine squared x minus sine squared x plus 2 sine x cosine x times sine x cosine x. And then you can say that this is equal to sine squared x cosine squared x minus sine to the fourth of x plus 2 sine squared x cosine squared x. And then this can be so then you can do like the combining like terms here and here, and then you can say that this is equal to 3 sine squared x cosine squared x minus sine to the fourth of x. You can do it this way, or you can also do it this way too if you want. It doesn't matter how you do it, as long as you for product rule, it doesn't really matter, as long as you you understand how to do it pretty well. As long as you understand the you don't have to simplify the trig functions and stuff. Now, as far as quotient rule goes, for that one, yes, sometimes you will have to do that, because sometimes when it comes to quotient rule, whatever's on the bottom sometimes, and there are instances where it can cancel out. So yes, you will have to watch out for that when it comes to quotient rule, but for product rule, you won't really have to worry so much about that. Okay, so now we're just gonna do quotient rule, only because, like I said in the beginning, I was only gonna do I was only gonna do product rule or something like that, but in reality, yeah, I mean, I know that with basically product rule and chain rule are probably two of the most important methods of derivative. So we're gonna get started on product rule. Quotient rule, excuse me. So yeah, like I said, I don't know if I said it, but product rule and quotient rule are two of the most important ones. Chain rule is also very important, but I'll go over that in the next video. But we're gonna go into what is it, quotient rule now. So give me 1 second, guys. So this is the quotient rule, okay? So for the next 30 minutes, we're gonna be working on this one. Now, the quotient rule is very similar to I keep saying chain rule, oh my goodness. The quotient rule is very similar to product rule, but there are two major differences. Number one, instead of adding, you subtract, and number two, you also include the denominator squared. So we're going to go over a few of these. I'm going to try to go very simple. So, for example, this one here. So let me see, hold on, actually. Okay, so let me do 5x squared, so the derivative. So let's see, f of x give me a second, guys, hold on. So f of x equals 5x squared over 4x plus 3, okay? So obviously this is of the form f over g, and we can color code. So we can say that this is equal to 5x squared, and then the bottom is equal to 4x plus 3. Now, we can find the derivative of both. We know that f equals 5x squared. G equals 4x plus 3, okay? And f prime, so if we do f prime, that's just going to be the power rule, so it's going to be 2 times 5x to the 2 minus 1, which is just 10x, right? So that's how we would do it. That's how you would do it. F prime is 10x. G prime is just the slope of 4x plus 3. What is the slope of 4x plus 3? That's just 4. Okay. Oh, and my bad, I used the wrong color. G prime is just 4, okay? Now you're going to go ahead and plug it in, so you're going to say f prime, so you're going to say f prime, that's 10x. So basically you're going to say the following. dx of 5x squared over 4x plus 3 is going to equal to f prime, so it's going to be 10x times g, which is 4x plus 3, minus g prime, which is 4. And I highly recommend that you put a bracket like this, because sometimes, because like right here, you're going to have to distribute the negative at the end, okay? So it's going to be minus the quantity, and it's going to be 4, right? G prime times the quantity f, which is 5x squared. And then it's going to be all over, and then you're going to do the bottom squared. So it's going to be the following. 4x plus 3 quantity squared. Okay. So then you're going to go ahead and distribute and do all that stuff. So then you're going to have 40x squared plus 30x minus 20x squared, right? All over 4x plus 3 quantity squared. Okay, so then you're going to go ahead and try to see if you can. So basically here it's going to be 20x squared plus 30x over 4x plus 3 quantity squared. Now go ahead and simplify this, okay? And this is what I'm talking about. This is going to cancel out, okay? So this is why I was saying whenever you do this, always make sure that nothing that like whether or not you can cancel something out, because sometimes they're going to give you problems like these where at the bottom you're going to have to cancel out. The one thing I wouldn't do is I would not FOIL the bottom. Like I would just keep it as this squared, okay? That's how in math, that's how they do it in calculus. They don't do the bottom, like they don't simplify the bottom. And the reason why they don't do that is because there's always, I mean, just in case it cancels out, okay? So anyways, we have 10x times 2x, so it's going to be Okay. It's going to be 10x times 2x plus 3 over 4x plus 3 quantity squared. I know I said it was probably going to cancel out. Yeah, I messed up. I thought it was. Never mind. It doesn't. So basically, you're just left with, and I believe this is the answer they got, if I'm correct. Yes, this. So you can just go ahead and put it back in. So you can say 20x squared plus 30x over 4x plus 3 quantity squared. And this would be your answer. Okay. So this other one is 3x plus 1. So 3x plus 1 over 4x minus 3. So the derivative of this, again, you would do, so this is f over g, and let's make this equal to f of x equals, so f prime of x would be equal to, and then it'd be f prime g minus g prime f all over g squared. F prime, so we know that f is 3x plus 1, okay? F prime is 3. G is equal to 4x minus 3. G prime is 4. So let's plug it in. Let me actually, hold on. It looks like this, hold on. So, like that. And then, like this. And then, this is f prime. Oh wait, no. My bad, no, hold on. Let's make this, hold on, let's make this f prime. So this is f prime, and then g prime can be like this. And so this is just f, and then the g squared part, that's just, the g is just highlighted, just g. Okay. So this is going to be 3 times, and then what's g? 4x minus 3 minus, and then we have g prime, that's 4 times 4x minus 3 all over 4x minus 3 quantity squared. So then we simplify this. We have so it'd be 12x minus 9 minus the quantity 16x. So let's put this in brackets. 16x minus 12 over 4x minus 3 quantity squared. So then we have 12x minus 9 minus 16x plus 12 over 4x minus 3 quantity squared. And then we have that this is equal to negative 4x plus 3 over 4x minus 3 quantity squared. Okay, so what do you notice about this one? Yeah, this one, so this one, if you look at it, you can factor out, right? Some people just leave it like this, but honestly, that's why you have to make sure you understand algebra extremely well. This is equal to negative the quantity 4x minus 3 over 4x minus 3 quantity squared. And this would be equal to negative the quantity 4x minus 3 over 4x minus 3 times 4x minus 3. These two cancel out, so you're left with negative 1 over 4x minus 3. And that would be f prime of x. Okay. Okay, so the last thing I want to do for this section is I want to explain how, like, I want to do the derivatives of tangent x and then also sine or cosecant x, secant x, and cotangent x. So the way I'm going to do that, so we have tan x, right? We know that this is equal to sine x over cosine x. So this one is going to be, so we have, we're gonna do quotient rule, okay? So this one's gonna be, let's see, so it's gonna be f prime g minus g prime f all over g squared, right? F prime, so we know that f equals sine of x, g equals cosine of x, so f prime is cosine of x, g prime is negative sine of x, okay? And we can find the derivative of tan x, okay? So we can say f prime g, so we can plug those in if we think about it, because if you do it like this, hold on, like this, like this, like this, and then like this, you can do f prime, so f prime again is this part, and then g is the other part, so it's this one, and then g prime is the dark blue one, so this one, and then f is just the yellow one, okay, so this one. And then g squared, that's just, it's g, so it's the lavender one, so this one. Okay, now we're gonna go ahead and do this, okay? So we have f prime, which is cosine of x, times g prime, or actually no, f prime times g, which is also cosine of x. So we have cosine of x times cosine of x minus the g prime, so that's going to be minus negative sine of x And then we have times f, which is sine of x, all over g squared, which is cosine of x quantity squared, right? So then we have cosine of x, or cosine squared x rather, and then we have a minus negative sine x times sine x. That's going to be minus negative sine squared x over cosine squared x. This simplifies to cosine squared x plus sine squared x over cosine squared x. Now what is cosine squared x plus sine squared x? That's just going to be 1 over cosine squared x. 1 over cosine squared x, that's going to be secant squared x. So that means that the derivative of tan x equals secant squared x. Now what about the derivative of cotangent x? Well, you're going to go ahead and do the derivative of the top. So cosine x prime times sine of x minus the derivative of the bottom, sine of x prime times cosine of x all over sine squared x, because it's sine of x squared, so it's sine squared x. So then you have negative sine of x times sine of x minus cosine of x times cosine of x all over sine squared x. This is equal to negative sine squared x minus cosine squared x over sine squared x. This is equal to negative the quantity sine squared x plus cosine squared x over sine squared x, because you can factor out the negative. This is then equal to negative, and we know that sine squared x plus cosine squared x is 1, so we have negative 1 over sine squared x. And this simplifies to negative cosecant squared x. Okay. So we know that the derivative for cotangent x is just negative cosecant squared x. Okay. If we do the derivative of cosecant x, so this is equal to, so we have dx of 1 over sine of x. In reality, we're going to have 1 prime sine of x plus sine of x prime times 1, or actually minus, excuse me, you see, it can get very, like, it can be very, what is it called? Tedious. So it can be minus, so you have minus cosine of x times, or actually minus sine of x prime times 1 all over sine of x quantity squared. So this is going to be 0, because 1 prime is 0, times sine of x minus, and then we have sine of x prime, that's cosine of x, times 1, all over sine squared x, okay? So then this is going to be negative cosine of x over sine squared x. This is, in reality, it's negative cosine of x over sine of x times 1 over sine of x. And negative cosine of x over sine of x, that's negative cotangent x. And then 1 over sine of x is cosecant x. So what is the derivative of cosecant x? That's really just negative cotangent x, cosecant x. Okay, and then I'm trying to think about, okay, so I'm going to do one more. d dx of secant x, and this is the last one. Now this one is going to be d dx of 1 over cosine x. That's going to be 1 prime cosine x minus cosine x prime times 1 all over cosine squared x, okay? And then you have 0 times cosine of x minus negative sine of x times 1 over cosine squared x. This is equal to 0 plus sine of x over cosine squared x. This is equal to sine of x over cosine squared x, which is then equal to sine of x over cosine of x times 1 over cosine of x. This is equal to tan x, and then this one is equal to cosecant x, or secant x, excuse me. So then you have the derivative of secant x is just tan x secant x. Okay. Okay, guys. I believe I did most, if not enough, for this part. So I did do product and quotient rule. If anybody has any questions, please let me know. Also, in the next video, what we're going to be doing is chain rule. Okay, so that'll be in the next video. But yeah, with that being said, guys, thank you so much for watching. Please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.